So hash table stores data values.
Sorry, hash
Hash table stores data values.
data.
Values.
Only data values only going to store hash table. Is there any?
Hash table
Only
stores
hash values.
the hash values and keys.
Yeah, hash table is contains two columns. One column is for storing the or
Hash value,
representing the hash value. Another one is for
actual
data.
data key.
Yeah. The actual data. Always actual data is depending on what? In hash table?
Hash value.
Very good. Right. What is hash function?
It is a function which is used to process the actual data and give an hash value.
Yeah, very good. Yeah, 100% right. Here it is going to convert or process your input data to hash value. Now, whenever you want to insert a data in a hash table, your hash function is going to convert the input data to the hash value. Now, your input data is stored in the hash table based on the hash value. So this is the basic idea. Yesterday we discussed same thing. Here, that is why when you are going to insert and delete and search whatever the operations we are going to apply on the hash table, here it must follow same process. Here that is why here when we are using this hashing mechanism for the data structure, it is going to take only one comparison, that is a constant comparison. Only one comparison we are going to identify that particular element is existed in this hash table or not. So that is why here the time complexity of hash table is constant. That is big O of 1. Clear?
Yes, sir.
Clear. Now, if you compare the dictionary to the hash table, here hash table, when you are going to insert n number of elements, also the comparison is required only one. But when goes to the dictionary, if you are going to increase number of elements, it requires that many number of comparisons. But hashing technique is it is going to avoid that problem. You can insert n number of elements also. Here the time complexity is only constant. Accepted?
Yes, sir.
Yes. Now I will share my screen, then you can again, if you want, again I will show the block diagram of hashing technique. That is very important. Here, is it visible now? Is it visible? My screen is visible.
Yes, sir.
Yeah. Now, already I told you very clearly in the yesterday. Again, I am giving some information. You know, that this is the hash function. This is the hash table. Hash table is divided into two parts. Here, one column is for hash value. Another is column is for actual data we are going to store. Here, when we are going to store this particular actual data in your hash table data structure, here you have to send that particular input data, maybe the actual data or key, to the hash function. Here, what is the job of hash function? Hash function is going to convert your actual data to some hash value, some code it is going to generate. Now, based on this code, here our hash function is going to store this actual data in that particular hash table. Maybe if it is generated 0 for your input, the input is stored in the 0 indexing. If it is generated 7, now this input is stored in the hash table at the record of 7. Here means always it is depending on the hash value. Hash value is nothing but it is a converted value from the input with help of the hash function. Here, same meaning we have to use in the further semester, that is the encryption. Encryption means we are converting your input data to some output data. This is encrypted data. This is cipher data. People will tell in a security subjects, they will tell it is a cipher data. Cipher data means plain data, input data. Encrypted data means converted data. Nothing but here we are telling it is a hash value. This is a basic data structures. That's why if you understand this hashing mechanism, it is going to help a lot. So that is the reason here hash value is nothing but hash value is completely depending on the hash function as well as input. Because whatever the input we are giving to the hash function is going to convert this input to the hash value. Now, based on this hash value only, our input is going to store into the hash table. Now, clear that? Is this clear?
Yes, sir.
The same way we discussed about one example yesterday. Here, if you consider here the hash function is h of key equal key percentile 100 means key is nothing but input data means input percentile 1000 has taken. Here simply hash table is divided into two columns. One is hash value, another one is the input data. If you want to store this input data, it must be depending on the hash value. Yeah, that's why this hash function is going to generate always hash value. This hash function always generates hash value from input data. Please, so this is very important. Here, from input data, hash value is generating. Here, that is generated by hash function. Here, based on this hash value only, our input is going to store into the hash table. So that is why here any hash function you can implement as per the requirement from the client. Here it is not an issue because hash function implementation is very important role. But once the hash function and hash table implementation is done, now the hashing mechanism will work very smoothly. Here how it is. For example, already I told you that the input I given 74010. This is input. Then tell me what is the hash value from this input data or maybe the key? Yep, 10. Now the hash value is 10. Now hash function is going to search 10th location. If it is 10, now hash function is going to insert this data in the 10th record of hash value 74010. Understand? Understand? Hello?
Yes, sir.
Even same record, if you want to search, what you are going to give as an end user, you don't give hash value. You are giving only input data. Now I wanted to know 74010. Here it is there or not. Again, you are giving input to your hash function. Then hash function is generating again hash value. The same hash function you are using. Then what is the output for 74010 in this case? For searching case, what is the output? What is the output?
10.
10 only. Now, here directly it is going to move to 10th record. Now, how many comparisons are required here?
One.
That is why if you take n number of records also, if you are using hashing mechanism, here it require only one comparison. That is why the time complexity is constant time. That is big O of 1. Whatever I told you, same thing. Correct? Correct.
Yes, sir.
Now today we are going to learn, now you know already hash table, what is the hash table, what is the hash value, what is the hash function. Now today we are going to learn types of hash functions. Means here I given one sample here only, but we have four types. Basically, as for the academics, I am telling four types of hash functions are there. Here real world we are having so many hash functions. Here as per the academic syllabus, here I am going to provide four categories of hash functions. Here means what type of function we can use here because table hash table is same and this block diagram is same. Input hash function has to do the process and convert the hash value. Based on the hash value, we are going to insert. This process compass already I told you that this is a block diagram. We have to use every time this diagram only. That's why you remember this. Okay, but here different hash functions we can use as per the requirement from the client. We can use different hash functions. Then the implementation of hashing technique is going to play a good mechanism. That's why we have basically four types of hash functions. Today we are going to understand hash functions. The first one is the division method. The first one is the division method, very easy method. This division method is very easily you can implement, and most of the cases the normal users, especially the academicians, and a simple hashing mechanism, if you want to implement, then you choose the division method because the division method is easily we can implement. So that's why division, most of the academicians, most of the people, they are going to use division method for hash function. Here, what is the division method? Here, the division method is very, very simple. Here, we are going to divide with means percentage of some data, divide with some data. The remainder we are going to use as a hash function from this hash function. The remainder is a hash value from this hash function. Here, for that one statement I am going to read, then you can understand here. The hash function depends upon the remainder of division. The hash function depends upon the remainder of the division. The divisor is table length. The divisor is table length. Means I will tell you. Now I want to implement a hash function. For example, I want to implement a hash function. Which hash function it is? Tell me which hash function it is? Which hash function we are discussing?
Division method.
Division
Division
method.
method. Because why I am asking is you people are following or not? Because after lunch, right? Right. In this division method, the division method is going to produce the hash value. That hash value is a reminder of that particular division. So that is a hash value. Based on that hash value, we are going to insert the records in the hash table. And one more point also they are mentioned very clearly. The size of the table is the divisor. Whatever the divisor we are using, here what value you are going to use, here that much size you have to consider as a hash table. For example, here I am preparing my hash function. Please carefully observe. It is very easy. I am filling K is my input. Okay. Now K percentile by here. Now I want to use 10 for this hash function. For example, I want to use 10. Okay, don't think always 10, anything you can take it. Divisor method, right? This is division method, right? Now, what is the size of the table I have to consider in the hash function? Tell me now.
10.
Yeah, very good. The hash table size must be 10. 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Means this is 0 indexing, 1, means it is what? Hash values, right? Are you clear? Table is divided into two parts. One is hash value, another one is the input data. Yes or no?
Yes, sir.
Yes, sir.
Yeah, very good. Now, initially, one value has came 54. Now we have to apply. This is the input. Here you want to insert into this hash table data structure. Here now before inserting this record, we are going to generate a hash value. That means when you want to generate the hash value, you follow the block diagram. What it is? You must be convert hash value from this input data with help of hash function. Just I am feeling this is my hash function I am considering here. Now tell me here 54, 54 divided by 10. Then what is the output here?
4.
Here 4 is the hash value. Now where we have to store this input value?
Fourth index.
We have to store at fourth index. Very good. The 54 is going to store here. Now tell me what is the 72 hash value? What is the 72 hash value?
2.
Here for convenient, I have taken divisor 10. You can take other numbers also, 13, 14, some complex numbers you take it. For discussing, for understanding purpose, I have taken percentile 10 only. Please don't think sir has taken 10 only. It is easy. Okay. For understanding, I have taken 10. You can take anything. Not a problem. It will work. Now next element is what? 89. Then where it is going to store? Where it is going to store? 89.
9.
9. The hash value is 9. Then again, 37. Where it is going to store?
7.
Yeah, this is inserting, right? We are inserted, right? Elements? Yes or no?
Yes, sir.
Yes, sir.
Now you want to search one element. You want to search an element. You tell me what element you want to search. Any element, you tell me. You want to search
54.
54. Now again, whenever you want to apply search operation also, we have to use same block diagram. Then we have to give this 54 as an input to hash function, correct? Yes or no?
Yes, sir.
Now what is the 54 hash value now? Again, our hash function is going to use same hash function. What is the value it is going to produce?
4.
4. Now 4 will come. Here 4. Now it will check fourth index. Yes, 54 is available. Now it is going to tell yes, 54 is there. Now how many comparison has taken?
1.
1.
Yeah, one comparison. That is the constant. That's why here if you are use 1000, use at 1000 means table size is 1000 elements. Then you can insert it. But your comparison time is constant time. That is big O of 1. Are you clear now? Are you clear?
Yes, sir.
For example, sir, why should we take percentile 10? It is very easy. I want to take the hash value is different value. For example, key divisor 4. If you want to take it 4. 4 means very simple number, right? You can take it 12. Correct? Hello? Just we'll check it. 12. Are you clear?
Yes, sir.
Now, table size is how much? What is table size in this case?
12.
12.
Sir, I am giving the idea you can use any number, okay, any format. 0, 1, 2, 4, 5, 6, 7, 8, 9, 10, 11. You can draw like that. Okay. Now what is the first value? 54. Now what happened? 54 percentile 12. What is the output? Tell me. Okay, this study is very easy. You can tell. Then come to the percentile 12. What is the value?
0.
Huh? What is the value? 54?
6.
We want reminder, right? How to calculate reminder? 12, 54. Tell me.
12 6 are 54. Reminder will get 0.
12, 6 is 54. Your reminder is 0. Now the value is what? Hash value is 0. Now
0.
where we have to insert this 54?
At 0 index.
At 0.
Understand everyone? Next element is 72. Here. 72 percentile 12. What is the reminder?
6.
6 only? 56?
0, sir. 0, sir.
0?
Sir, 54%
12 is 6.
12, 6 how much?
70.
72.
Yes, 0 only. Here, this is called This is called, actually this is called overflow. We will discuss. This is the error. Means already 54 is occupied with zero indexing, right? Hello?
Yes, sir.
Hello? Already 54 is already occupied with zero indexing. Now again 72 also wants to insert in this location. This is called collision. The next topic is the collision. First of all, understand the types of the functions. So this is the collision. This collision we are going to overcome. This is the last topic. We will discuss it. Don't worry. Understand? Understand? Don't confuse here.
Yes, sir.
That's what I have not told here. Okay, you can understand collision. So this is called collision. Means here same room more than one element want to occupy. Same room more than one element is going to occupy. It is called as collision. It is called as collision. To overcome collision with help of some techniques, here I will discuss after understanding of types of hash functions. We will go with one by one collision or flow overcoming of the collisions we will discuss. Clear that? Don't think about collisions now. I will tell you. Now anyway, one topic has came. This is called collision. Clear? Clear?
Yes, sir.
Yeah, please remember this point. Anyway, I will tell you again. Okay, right. Next, first of all, we have to understand hash function. Next, 89. 89 percentile 12. Tell me what is the position? What is the index value? What is the index value? '89 percentile 12. Please consider integer. Only
Yes, sir.
integer. Huh?
5.
5. Now it is going to insert it fifth location. Like that, you can insert, and same way you can search the element in the hash table using this division method. This division method is very easiest method. Understand everyone this division method? Understood everyone?
Yes, sir.
Yeah. Here the divisor always size of the table. If the collision will occur, what should we do? We will discuss. Every method we will get the collision compulsory. Here, anyway, we will get the collision compulsory. We will get the collision here, but we have some techniques to avoid the collision when we are going to develop the hashing mechanism. We will discuss that after completion of division methods. Okay, remember this collision term. Okay, this is very important. Compulsory, you will get the question from this collision. Okay, how to overcome the collision? Compulsory, you will get the question. The collision term also very important. Interviews also people will ask. Right. Now coming to the second method, mid square method. First method is clear, right? Division method is clear, right, everyone? Clear, everyone? Division method.
Yes, sir.
Yes, sir.
Right. Here coming to the mid square method. Here this mid square method is very simple method. Here we are going to square the given input value and you must square it and consider the middle element as a hash value. Before that, one more point I have to add here, division method. One more point I am going to add. Sir, here we have taken only the integer data, but I want to give integer data A, B, C, D. Now, first value A I want to insert, B I want to see, D. Here how to? Simple, you have to convert it, before that you have to convert into integer data, means numbers, means use ASCII format. Clear?
Yes, sir.
Means we can store the string also. We can store the string also in the hash table or any number you can store it. But if you wanted to store string into the hash table, you convert it into the number format using ASCII. Clear that?
Yes.
Yeah, please don't confuse. Okay. Now coming to the mid square method. Here already I told you the mid square method. Just we are going to square the given value. If the value is string, then again you have to convert using ASCII to the numbers and you square it and find the middle middle value, then you can use that middle value as a square. So for example, the input data is maybe the 15, then you have to square it, 15 square, the 225. Then I have considered 2 as a input data, 2 as a ASCII, what is this, hash value. Now I stored 15 at index of 2. Then the same way 17 square. Now I consider middle one 8, then it is stored at 8 index. Here any other number if we are going to insert, if we get same index, that is called as collision. We will discuss later how to overcome the collision. Understand this square method?
Yes, sir.
Any confusion?
No, sir.
Some people will ask, sir, after squaring, for example, anyone tell any number? Any number after squaring, it must be four digits.
10. 100.
10 square means how much? What is it, 10
100.
square?
100.
100. Again, only 3 digits are right. 0 you are
100.
going to store. What is the use? I am asking any number, the square must be 4 digits or 6 digits, even digits I am asking. Understand what I am telling? After square, the result must be even digits, means 4, 6, 8, like that.
12.
So 35 squares.
35 square. What is the 35 square? If the input is 35, then
1,
square it.
2, 5.
Sorry?
1, 2, 2, 5.
1, 2, 2, 5. So now people will ask, sir, here 4 digits are there. How to find the middle number? Correct? Question is
Yes.
right or wrong? Yes or no?
Yes, sir. Yes,
Yes,
sir.
sir.
Here we are not mentioning this is only idea mid square. You have to square it and find the middle number. Here, before applying your method, I am telling, before applying your hashing mechanism, first of all you go through your input data. You must verify with your input data. Here, based on your input data, you decide which technique, which hash function is suitable. Here, the hash function division method is suitable, bit square method is suitable, multiplicative hash function is suitable, or digit folding is suitable. First of all, you must be identify which is the suitable for my input data. Yeah, that is as an engineer you are going to identify because you have to learn very clearly. Yeah, based on that, you have to practice. After practicing, you can decide, oh, this is my data. Now it is suitable with mid-square method. Yes, I am going to use mid-square method now. Sir, when you are using mid-square method, again you have to go through with your input data. Sir, when after squaring, my data is producing uh, 3 digits or my data is producing 4 digits. Here, if the data is producing only 3 digits, for every data it is producing only whatever the data I am going to store, all data after squaring, it is producing only 3 digits, then use middle number as a hash value, only one number as a hash value. If it is producing, means even number, maybe the 4 digits, 6 digits, 8 digits, then you consider middle two numbers as a hash value. Understand?
Okay, sir.
Now you can insert this where? This 35 you are going to insert into where? This 35 where you have to
22.
insert?
22.
Here, at the position of 22, you are going to insert. Even searching also, when you want to search this 35, you have to square it, find the middle number, and with only one comparison, you are going to find. Understand?
Yes, sir.
Any doubts here in this mid square method?
No, sir.
Very easy actually. After learning this second unit, you people will tell, everyone will tell, sir, I am more comfortable with second unit because practice. Sir, again, I am telling you practice it. Without practicing, maybe sometimes confused, but after practicing, you will tell, sir, this is very, very convenient unit. Now coming to the third mechanism, multiplicative hash function. So this is somewhat typical hash function, multiplicative hash function. Sure, you know Already division method and mid square method, both are easy. But in this multiplicative hash function, you have to remember some points. Your multiplicative hash function is simple. The given record, the input is multiplied by some constant value. Means you are going to multiply with some constant value. You are going to multiply with some constant value. Whatever the input they are given, you are going to multiply with some constant value. Here simple, the mechanism is here 5 into, for example, the input data is 5. Now I am going to use 25 for my multiplication. Are you clear?
Yes,
Are you
sir.
clear? But when you are using only these 2 points, it is taking what happened 25 into 5. What is the value?
125.
125. Now we have to store at 125 indexing of this 5. We are going to store at 125. Here this is taking big. Here that's why here Donald North is suggested one mechanism. Donald North is suggested one mechanism. If you consider this hash function for multiplicative hash function implementation, here your hashing technique is going to provide 99% without collision. You know what is the collision, correct?
Yes, sir.
Yeah. Means when we are going to insert same number, it is already inserted, that room is allotted another number. We want to insert one number, already the room is allotted, then we will get the collision. That collisions, if you want to avoid, use my multiplicative hash function. You mentioned very clearly, use my multiplicative hash function. Here, what is this multiplicative hash function? I will tell you. Here, simple. Here, the fractional part of key, nothing but it is a key, means input data. Are you clear? Means whatever the input we are going to insert in this hash table, here that is the input. Clear? Clear?
Yes, sir.
Yeah, this input you must multiply it with A. Here A is a constant real number. A is a constant real number. You can take any number. It's A equal to real number means, what is the meaning of real number? Anyone can tell? Please tell me, anyone. What is a real number? Hello? What is the meaning of real number? Are you there? What is the real number? You don't know the real number? Hello? Hello? My voice is audible?
Yes, sir.
Yeah, my question is, what is real number?
Which contain both rational and irrational numbers.
Yes. Very good. Nice. You respond to things. Okay, right. Now, here generally fraction part, the number which contains fraction part, then you can tell it is a real number. Then I will take 0.5, point something, 0.6, 0.1, whatever the number you can use. But Donald North is mentioned. If you want to use a value, the real number may be like this. After his research, after he found a value, if you use 0.61803398887, if you use a value like this, here you can not get collision. 99% you cannot get the collision. But here, as per the multiplicative hash function, you can use A is any real number, not a problem. A equals 0.5, you can take it. A equals 0.3 also you can take it. Any number you want. Same real number you can use for all the operations, not a problem. But the scientist Donald North is worked on this more, and he found if you use a value is 0.61803398987, it will be produced a hash table which is without collision until 99%, it never produce any collision. So this is the Donald North is suggested for this multiplicative hash function. If you don't want to use not constant value a, then you can use a value is any real number. A equals 0.2 or 0.3, 0.5, whatever the value you can use. Understood now?
Yes, sir.
Yeah. Now, already here very clearly mentioned the key event record is multiplied by some constant. Yes. Here this is going to multiplied with some constant. That is what P. P is a integer constant. You can take P value any number. Here you can take any number, not a problem. If you want to take 25, yes, you can take it. If you wanted to take 5, yes, you can take it. Yeah, this constant always same for all the operations. Like the A, how real constant, how we have taken, same number, same way you can use P is a real, is a integer constant, A is a real constant. Here compulsory you have to multiply. Here after this you have to apply floor. Floor means here after performance of this, maybe you will get some fraction parts. For example, 7.55. The floor means we have to consider only what we have to consider. Floor means you won't consider fraction part. You have to consider, yeah, you don't consider this fraction part. You have to consider only this integer part. So that's why here we have to apply floor. Here this is the multiplicative hash function. For example, if I take a value is Donald North constant, here now I want to insert 5. Now I want to insert 5. Then here I have taken the integer constant P is 25. You can take any number, not a problem. If you want to use Donald North constant A also, you can take the integer constant any number. Or if you don't want to take Donald North real constant also, you can use real constant any number. It is not depending on anything. That is up to you. As per your data requirement, as per the experience, you can understand which number is suitable for this real constant. Right. Now, just we have to apply 4 of 25 into what is the 25? Integer constant. Then 5 is your integer data. Then multiplied with Donald North constant A value, real constant. Then we'll get 77.254 something. Now we are applied floor, right? Then we will get 77. Here now 5 we have to store it where? At the index of 77. Understand? Understand this?
Yes, sir.
No, I don't want to use Donald North constant. I want to use my own constant. Then we can use A value is, because it is a real constant, right? 0.5. P value is integer constants. I will use 5. Now, what is the input value I want to insert? 5. Yes or no?
Yes.
You can take these two values, any numbers. There is no any constraint. You can use any real number for A. You can use any real number for any integer number for P. Understand? Understand? Hello?
Yes, sir.
Yes, sir.
Only one case, if you want 99% collision-less data structure, then you can use this Donald North real constant. Otherwise, you can use anything. Then I'm going to do this without Donald North constant for multiplicative hash function. What should I write? Floor of what we have to do it. What is the p value? P is 5. You can take any value, P value. Now, what is the input data? 5 into what is the real constant? 0.5. Tell me. What is the floor of? What is the value here? 5 into 0.5. How much? 5 into 0.5. 2.5. 2.5 into 5?
12.5.
12.5.
12.5.
5.
Now, what is the floor value?
12.
12.
After floor, 12. Now, what is the index? 12. Now, where we have to insert? Is the 12th index, we are going to insert your 5 input value. Understand now? Understand now?
Yes, sir.
Yes,
Sir,
sir.
in the same way, if you want to use not real constant, you use like this. If you don't want to use not real constant, if you want to use your own constant, use like this. But both the cases, the integer constants, you can take your own value. Any number you can take as any integer number, you can take it as a integer constant. There is no any condition. Please remember, don't by heart the things. Whatever I am telling, you must be understand. Multiplicative as function means you have to multiply with some integer constant and some real constant. Here, this is the idea. Here now, once we are implemented this data structure using this constants, real constant and integer constant. When you want to search also, you have to use same constant. Don't change these constants after implementation. If you use this for all the operations, you have to use this only. If you use this for all the operations, you use this only. Or if you want to use a value 0.75, you can use it. P equal to 20, you can use it. But the problem is, the situation is, you must be use same constants, same hash function for all the operations. Then only it will be work. Understand? Understood this? Multiplicative hash function is understood everyone.
Yes, sir.
Yeah. If any doubt is there, please ask me, because here only the samples we are discussing here. Here later we are going to discuss collision. In that collision time, we can understand more clearly. This is basic methods I am discussing. Clear this multiplicative hash function?
Yes, sir.
Yeah. Now coming to the last mechanism, very easiest mechanism, digit folding. The digit folding is nothing but very simple. We are going to divide the data, input data. Here also same, your multiplicative hash function also. Don't think always input value is integer, but easy understanding, I have taken input value is 5. But you can take strings and characters also. You have to convert to numbers using ASCII format, correct? Everywhere same. Understand?
Yes, sir.
Understand? Yeah. In this now last method for as function implementation, digit folding. The digit folding is a mechanism we are going to divide your data into number of subparts. After dividing of subparts, we have to add all the subparts. Then after adding, we will get some number. Then you can feel this is a hash value. For example, folding means we have to fold the data. Simple. For example, the key is divided into separate parts, and using some simple operation, these parts are combined to produce the hash key. Means here this is the input data they want to store in the hash table. Now they have taken here three numbers 1, 2, 3, 6, 5, 4, 12. Here 1, 2, 3. They are considered one part. This is another part. So now they are taken 1, 2, 3 plus 654 plus 12. Then finally we'll get 789. Now they are going to store this value at the position of 789 as value in the hash table. Understand? Very simple mechanism. Understood this? Understood this?
Yes, sir.
Sir, folding is nothing but not only addition. Some people will confuse. Sir, as per your requirement, you can use this folding mechanism. For example, 1, 2, 3, 4. Now I want to store this data. Sir, why you have taken three digits? As per the requirement, I have taken. I will take one digit also. 1 plus 2 plus 3 plus 4. What is the output? What is the output?
10, sir.
10. Now we are going to store this 1, 2, 3, 4 at 10th indexing of my hash table. Because here in the same digit folding only I am using, but in this digit folding I am using, I don't want to use 3, 3. I want to use 1 number. then you can use it. Not a problem. This is also digit folding. If digit folding means don't confuse compulsory. You have to show like this only. Means folding means you have to add all the sub data together. That is the meaning. Here, one more thing also I will tell you. No, sir, I don't want to use plus. I want to use another symbol. Yes, you can use one first addition, next subtraction, next addition. But this plan you must be implement for all the cases. Means here what I am doing, first addition, next subtraction, next addition. For all input data for insertion, for deletion, for searching, you have to use same format. Addition, subtraction, addition. Understand? Here what I have taken? All additions. Yes or no? Then what is the output? In this case, what is the output? What is the output here?
4, sir.
4. Now we are going to insert 1, 2, 3, 4 at fourth indexing of your hash table. Sir, why should we use only plus and minus? I want to use multiplication also. Yes, digit folding, you can use anything. But same formula you must use for all the input data for all the functions. Don't change the formula. If you want to use this formula, you use for entire your data structure this formula only. For example, first I want to use multiplication. Next, I want to use subtraction. Next, I want to use division. Now, tell me, ఇక్కడ కొంచెం ప్రాబ్లం అవుతుంది కదా క్యాలిక్యులేషన్కి ఇక్కడ one division, one multiplication, two. We will take another input. Some division problem will come. You can take anything. That is what my suggestion is. 4. What happened? 4, 3, 2, 1. This is the data. Now I want to use another mechanism. Means first I want to apply. First I want to apply multiplication. 4 into 3. Next I want to apply subtraction. Next I want to apply division. Like this. Understand? But this format is same for all the cases, all the input and all the operations. Understood, everyone? Understood?
Yes, sir.
Yes,
Yeah,
sir.
this is very actually this digit for this hashing mechanism is ocean actually. I published one paper actually on this with using complex tools complex. I think you don't have still it is not done. I think what is tools complex, trees complex? It is not done right in your CO.
No, sir.
After that, you can understand. Okay, no problem. That is also another case. It is not there. Now, understood this digit folding method? Understand?
Yes, sir.
You can use anything. Here, you can use anything, but that must be same for all the cases. Yeah, these are the 4 basic hash function methods are available. As per the academics, I am discussing these methods. Actually, here in we are having so many methods outside. People are going to based on this only. Actually, basically these 4 methods are only we have to use. Sometimes people will be combined these methods. For example, first I am going to use division method. After division method, we get hash value is 1, 2, 3. For example, after applying of division method, we get hash value 1, 2, 3. Here on this division method, again I am going to apply mid square method. Here again means 1, 2, 3 I will get right. Again I have to square it. And again I have to consider middle value. Understand what I am telling?
Yes, sir.
Here after getting mid square value, after getting mid value, or maybe mid value is 2, 3, 4, like this mid value has came. Maybe if you think like Then you can apply digit folding also. Means at a time we can apply 3 to 4 mechanism. Now, this is real-time examples I am telling. At a time we can apply 3 to 4 hash functions to provide more benefit to the user. Understand? But as per academics, individually only enough. Understand this?
Sir.
Yeah, in your textbook it is not there actually. Hashing mechanism is not there. Please follow some material and follow my notes, then you can understand. Clear these methods?
Yes, sir.
Right. The next topic is collision. In the next class we will discuss it. Here already I told you what is the collision. What is the collision?
Two functions written same.
Not two functions. Two values. The hash function, it is going to reduce, it is going to produce same hash value for two input data. Means two input data is trying to occupy same room in a hash function here, which is called as collision. So the hash function returns the same hash key for more than one record is called collision. Understand now collision? Understood? The first example itself only we got collision, right? Yes or no? For 54 percentile 12,
Yes, sir.
22% 12, we got 0 only. This is called collision. Both are trying to occupy same room. Here this collision. Now, how to overcome these collisions? Here, what are the techniques are there to avoid these collisions when we are going to implement the hashing mechanism? Here we have 6 to 8 methods. We will discuss in the next class. Once it is going to complete, your 6th unit is going to complete it. Clear now this hashing techniques now? All of you
Yes,
clear
sir.
this? Yeah. Here anything is there in the next class, you please practice this. In the next class you can ask, then I will explain again, not a problem. But second unit, as per my observation, since from 10 years,